Good evening. Tonight we're going to have a broad overview of mathematical modeling. Before we get into, in our later lectures, creating specific mathematical models and using those models for research, and then determining the significance of our findings from that research. So first, an introduction to research methods. The descriptive research method allows a description of behaviors, and it usually has several different research methods associated with it: the observational method, the case study method, and the survey method. The predictive method also allows a description of behaviors, but goes farther and allows us to support reliable predictions from one variable to another. And the research methods associated with prediction are correlational method and the quasi-experimental method. And finally, we have the explanation, and that allows description of behaviors and supports reliable predictions from one variable to another, but goes farther in that it also supports cause and effect explanations. And the experimental method is the research approach for that. So again, descriptive methods include observational, case study, and survey methods. Predictive methods include correlational and quasi-experimental. When we question individuals on a topic and then describe their responses, we're using the survey method. And when we conduct an in-depth study on one or more individuals, we're using the case study approach. The method that assesses the degree of relationship between two variables is the correlational method, and variables increasing or decreasing together is positive correlation, and variables moving in opposite directions is a negative correlation. Explanatory methods include only the experimental method. And this is where we identify the causes that determine when and why a behavior occurs, and we can create a hypothesis, which is a prediction regarding the outcome of a study. There's also theories, and they are an organized system of assumptions and principles that attempt to explain certain phenomenon and how they're related. There's various scales of measurement we might use in our research. The four scales of measurement include nominal, ordinal, interval, and ratio. The scale determines the amount of information contained in the data. The scale indicates the data summarization and mathematical analyses that are most appropriate. Nominal data are labels or names used to identify an attribute or element. Can be a non-numeric label or a numeric code. For example, students of a university are classified by the school in which they are enrolled, and that's usually done using a non-numeric label such as business, humanities, education, and so on. Alternatively, a numeric code could be used for the school variable. For example, 1 denotes business, 2 denotes humanities, 3 denotes education, and so on. Ordinal data have the properties of nominal data, and in addition, the order or rank of the data is meaningful. Again, a non-numeric label or a numeric code may be used. As an example, university students are classified by their class standing with a non-numeric label such as freshman, sophomore, junior, senior, or graduate. Alternatively, a numeric code could be used for class standing where 1 denotes freshman, 2 sophomore, and so on. Interval data have the properties of ordinal data, and in addition, the interval between observations is expressed in terms of a fixed unit of measure. Interval data are always numeric. For example, we could say that Melissa has a GRE score of 1985 while Kevin has a GRE score of 1880. So Melissa scored 105 points more than Kevin. Ratio data have all the properties of interval data, and the ratio of two values is meaningful in addition. Variables such as distance, height, weight, and time use the ratio scale. This scale must contain a zero value that indicates that nothing exists for the variable at the 0 point. So, for example, we could say that Melissa's college record shows 15 credit hours earned, while Kevin's record shows 30 credit hours earned. Kevin has earned twice as many credit hours as Melissa. So the nominal scale has the property of identity. And so for the 4 scales of measurement, we'll look at the properties of those measurements. The ordinal scale, like the nominal scale, has the property of identity, and in addition, it has the property of magnitude. The interval scale has the properties of identity and magnitude, and in addition, the property of equal unit size. The ratio scale has the properties of identity, magnitude, equal unit size, and in addition, a true zero. So, let's provide an example of a variable measured on a nominal scale, ordinal scale, interval scale, and ratio scale. Nominal variables might include gender or ethnicity. Ordinal might include letter grades or class rank. Interval scale might have a Fahrenheit temperature and an SAT score. A ratio might be weight, height, or percentage grade on an exam. A scale of measurement in which objects or individuals are categorized and the categories form a rank order along a continuum is the ordinal scale. A property of measurement in which the objects that we have in our set receive different values is identity. A property of measurement in which the ordering of numbers reflects the ordering of the variable is magnitude. A property of measurement in which a difference of 1 is the same throughout the entire schedule is equal unit size. The property of measurement in which assigning a score of 0 indicates an absence of the variable being measured is absolute 0. Class rank is an example of the ordinal scale of measurement, and weight is an example of the ratio scale of measurement. An event or behavior that has at least 2 values is a variable. data can be further classified as being a categorical or a quantitative variable. The mathematical analysis that is appropriate depends on whether the data for the variable is categorical or quantitative. In general, there are more alternatives for analysis when the data are quantitative. Labels or names are used to identify an attribute of each element. These labels or names are often referred to as qualitative data, and they use either the nominal or ordinal scales of measurement. They can be either numeric or non-numeric, and appropriate mathematical analyses are rather limited. So again, categorical data are labels or names used to identify an attribute of each element. Quantitative data indicate how much or how many. Discrete quantitative data measures how many. Continuous quantitative data measures how much. Quantitative data are always numeric. Ordinary arithmetic operations are meaningful for quantitative data. The group of subjects that serves as a baseline in a study is the control group, and the group of subjects that receive some level of treatment is the experimental group. The manipulated variable in a study is the independent variable, and the variable measured in the study is the dependent variable. So a qualitative variable is a categorical variable for which each value represents a discrete category, while a quantitative variable is a variable for which the scores represent a change in quantity. Nominal data are qualitative, and ordinal, interval, and ratio data can be quantitative. And in the case of interval and ratio data, they are quantitative. One of the things we'll use in our models quite often is statistics. And statistics is the organized approach to collecting, analyzing, presenting, and interpreting data. And it has application areas in information systems, production control, accounting, marketing, and economics and finance. And again, statistics is a branch of mathematics that we use quite often in creating mathematical models. The term statistics itself can refer to numerical facts such as averages, medians, percents, and index numbers that help us understand a variety of business and economic situations. Statistics can also refer to the art and science of collecting, analyzing, presenting, and interpreting data. Let's go over some terminology that we'll use in our models. Data are the facts and figures collected, analyzed, and summarized for presentation and interpretation. All of the data collected in a particular study are referred to as the data set for that study. Elements are the entities on which the data are collected. A variable is a characteristic of interest for the various elements we collect data on. The set of measurements obtained for a particular element is called an observation. A data set with n elements contains n observations. The total number of data values in a complete data set is the number of elements, in other words, the number of people or the number of objects we're collecting information about, multiplied by the number of variables, in other words, the various attributes of each element that we're collecting information about. A frequency distribution is a tabular summary of data showing the number or frequency of observations in each of several non-overlapping categories or classes. The objective is to provide insights about the data that cannot be quickly obtained by looking only at the original data. So let's take an example of this. Here we see in Excel a set of raw scores, and it's from a restaurant, and the customers were asked to fill out a card that indicated whether they thought the service in the restaurant was below average, average, above average, or excellent, or poor. And you can see here the results. So this is the raw results, the raw scores from the particular cards. Here we've created a frequency distribution. We've counted up each value and the number of occurrences for each value. So there are 2 cards that were scored poor, 3 below average, 5 average, 9 above average, and 1 excellent. So this gives us a much quicker insight into how the restaurant is performing than the raw data itself. With a frequency distribution, we can also do a graph. So here, this gives us an even quicker visualization of how we're performing in that particular restaurant. Again, this is a graph of a frequency distribution. So you can see the value of a frequency distribution, which is the basis of all statistics really, is that it helps us more quickly understand the data that we're looking at in terms of a particular research question. In this case, the research question is, how is our restaurant performing? We can use graphs to help provide a visualization, which gives us a more quick insight into the information we're studying. And there's several types of graphs that we can use. A bar chart is a graphical display for depicting qualitative data. On one axis, usually the horizontal axis, we specify the labels that are used for each of the classes. A frequency, a relative frequency, or a percent frequency scale is used for the other axis. Again, that's usually the vertical axis. Using a bar of fixed width drawn above each class label, we extend the height appropriately. The bars are separated to emphasize the fact that each class is a separate category. So here we have a bar chart, and we've got the separation between poor, below average, average, and above average, and excellent. And the height of each one of the bars is equal to the frequency of the response out of the 20 cards that were collected. And of course, along the along the horizontal axis, we have the actual values for the rating that were given on each card. There's also a histogram, and that's another common graphical display of quantitative data. The variable of interest is placed on the horizontal axis, and a rectangle is likewise drawn above each class interval, with its height corresponding to the interval's frequency, relative frequency, or percent frequency. Unlike a bar graph, a histogram has no natural separation between the rectangles of adjacent classes because it is a continuum of values along the horizontal axis. And finally, we have a frequency polygon, which is a graph of the frequencies of individual scores. So, let's look at when we might use a bar graph versus a histogram. A bar graph is used when the data are nominal and qualitative. A histogram is used when the data are ordinal, interval, or ratio. A graphical representation of a frequency distribution in which vertical bars are centered above each category along the x-axis and are separated from each other by a space is a bar graph. A graphical representation of a frequency distribution in which vertical bars are centered above scores on the x-axis and each bar touches each other is a histogram. And a line graph of frequencies of individual scores is a frequency polygon. Next, we'll take a look about what are known as measures of location or central tendency. And these are statistics that with a single value or a small set of values determine or inform us about the characteristics of the data set that we're studying. Some of the more popular statistics are mean or average, median, mode, and we also can use percentiles. The mean is perhaps the most important measure of central tendency or location. Again, the mean provides a measure of central location and is the average of all the data values. It's the sum of the values of the n observations we have divided by the number of observations n, and that gives us our average or mean. The median of a data set is the value in the middle when the data items are arranged in ascending order. Whenever a data set has extreme values, the median is the preferred measure of central location. The median is a measure of location most often reported for things like annual income and property value data because these data sets tend to have extreme values. In other words, a few people who are making billions of dollars a year or who live in houses worth $50 million or more. So because of those extreme values, the median price is more meaningful. a few extremely large incomes or property values will grossly inflate the average. The mode of the data set is the value that occurs with the greatest frequency. The greatest frequency can occur at 2 or more different values. If the data have exactly 2 modes, the data are bimodal. If the data have more than 2 modes, the data are multimodal. So a number that characterizes the middleness of an entire distribution is a measure of central tendency. The mean is calculated by summing all the numbers in a distribution and dividing by the total number of scores. The mean can be used with both interval and ratio data. The median can be used with ordinal, interval, and ratio data. The mode can be used with nominal, ordinal, interval, and ratio data. So let's look at measures of variation. We have the average deviation, and that represents the average distance of all scores from the mean of the distribution. It's used only with interval and ratio data, and it's a measure of variation that uses all the scores. Standard deviation is the square root of the average squared deviation from the mean. Again, it's used only with interval and ratio data, and it uses all of the values in the data set, and it's the most frequently used of the measures of variation. In addition to the variability of the distribution of numbers, it's important to know about the shape of that distribution. Is the shape symmetric? Is it tall and thin, or is it flat? Based on these characteristics, we can mathematically do things with a distribution. An important measure of the shape of a distribution is called skewness. This, in effect, measures how lopsided a distribution is to the left or to the right. Kurtosis is how tall or flat a distribution is. Mesokurtic is median height and a moderate breadth. Leptokurtic are tall and thin, and platykurtic are short and broad. And range is a measure of variation where we only use the lowest and the highest scores and calculate the difference between them. So it doesn't use all the values in the data set, but it does give us a quick calculation for the variability we experience in the data set. And here we see the range and how it would be calculated for a particular application. Okay, and this is just a brief introduction into some of the concepts that we'll be exploring in more depth as we actually get into how we create mathematical models to describe problems and research that we want to conduct. and we'll be getting into those more in the upcoming lectures. Thank you.